streaming, but desktop audio.
Okay. You don't speak.
Thank you. Okay, I'll start. Um, good afternoon, Mr. Akshata and Mr. Saurabh. So I'm here with my team, Marshmallows, using Fetch AI and Power BI plus deep learning. So we have created a model plus a dashboard regarding the problem statement. So I have a
Plus
teammate
as well.
with Rag Khataria and Tristan Hancock.
It's
I
just keep
request
it
Tristan
very
Hancock
minimalistic.
to
One login for
go ahead with Fetch AI. So I'm here with my team, Marshmallows, using Fetch AI and Tristan? Power BI plus deep learning. So
I'm sorry, Tristan isn't here yet because he hasn't been added to the room. I'm just
Oh,
contacting him.
okay,
Just a minute.
cool. I
just
request
keep it
Tristan
very
Hancock to
minimalistic. One login for
go ahead with Fetch AI. Marshmallows, using Fetch AI and Tristan? Power BI plus deep learning. So
I'm sorry, Tristan isn't here yet because he hasn't been added to the room. I'm just
oh,
contacting him.
okay,
Just a minute.
cool. Hi Joey, can you add Tristan?
Okay, is he in the waiting room?
Yeah, he's saying he's in waiting room.
Okay, 1 second.
Yeah.
You have told them to let them in. Just give us a moment.
Sure.
Yeah, he's here.
Yeah.
Hello?
Hi Tristan. I just introduced myself and you are
Yes.
okay to go forward with Fetch AI.
All right.
Yep.
Just give us a moment.
Right. So I'll introduce myself then.
Yeah, I did introduce yourself. You can
All
just
right.
go forward with Fetch AI. Yeah.
All right. So good afternoon, judges. My name is Tristan, and I will be presenting our agents and how we have implemented Fetch AI's agents in order to solve Aryan's, business problems. Now, Aryan is not the best as business, as stated in the problem question. He has two major issues. One is the inventory management, and the second being untimely orders. Now, we have devised our agents such that we have a main agent named Marshmallow. Marshmallow speaks to our remaining three agents, Zach, Alan, and Rob. Now, what Alan will be doing is Alan is going to be managing his inventory entirely. It will allow, I will demonstrate to you completely what we can and what we can't do with Alan. And Alan is going to be taking care of our inventory completely. Zach is going to be managing how our time works and when we can set working hours in order to prevent untimely orders. And Rob is where our deep learning comes in, where Aryan will be able to understand how his business is performing, where his sales will be, how his sales are so far, etc. Now I will be sharing my screen. If I could just uh yeah, is my screen visible?
Yeah, it's visible. Tristan.
All right. Now before continuing with our project, I'd like to be very honest where his sales will be, how his sales are so far, etc. Now I will be sharing my screen. If I could just uh yeah, is my screen visible?
Yeah, it's visible. Tristan.
All right. Now before continuing with our project, I'd like to be very honest, etc. Now I will be sharing my screen. If I could just
Yeah, yeah, yeah. Yes, yes. Tell me.
Hey guys, can
Yeah,
you
yeah,
bring
yeah.
the team bit quicker? Because I can see the sheet
Yes, yes.
and
Tell
there are
me.
like more than 20 teams we need to judge. So yeah, I think it will take a lot of time if we spend this much time.
Yes, sir. We are trying to like bring the teams very quickly, but like there are some technical
Hey
issues, but
guys,
we'll get back as soon
can
as
Yeah,
you
yeah,
bring
yeah.
possible.
the team bit
Sorry
quicker?
to
Because I
make
can
you wait.
see the sheet
Yes, yes.
and no, I mean the number of
The waiting
participants are
time,
quite more.
we can reduce the waiting time, you can just ping the next team beforehand and let them in the waiting room, so that once team gets completed, we can directly move to the next one.
Yes, ma'am. Yes, ma'am. We'll do that.
and there are like more.
Guys, how long would it take to join the second round?
Ma'am, just a second. We are just trying to get the team admitted in the room. They have just joined the meeting, so we'll just get them admitted.
Okay.
Okay.
Hello, Sahil.
Hello.
Is your full team here?
Uh, I'm sorry, I can't hear you. Just a second.
All the members of your team are here.
Yeah, currently we two are only presenting. The third member is facing some network issues, so he won't be able to join.
So is it okay if if you guys can start, or you are going to wait for the third guy?
No, we are not going to. We are going to start. Sahil will be sharing the screen with the PPT.
Yeah,
Okay.
okay, I'll share screen.
Judges, this is team number 145.
Okay.
Yeah.
And can you
Let's
please
start,
make sure
guys.
that the next team stays quite ahead, of time, so that we can just skip with
I'm
them.
sorry, can you hear me clearly now? Because I was not able to hear you.
Okay. Okay, no worries. Sahil, you can start your presentation.
Sahil, please make sure that you finish the presentation in the 10 minutes time. Sahil?
Hello, Sahil. Are you there, or does the network issue you are facing?
Just a minute. I'll just check, verify it. 1 minute.
Okay.
Yeah, he is saying that he can't join because something like meeting capacity is full. Hello.
Hello. English.
Yeah,
So
yeah.
okay, there might be some issue. Okay, so just
Okay,
tell him to join, try to join again. Okay, and we will
okay,
check it that whether he will be available or not. We will try to get him in.
okay. Yeah, he is unable to join.
Darsh.
English, can you just tell him to join the waiting room? Because I am here with the host and he's saying that he's not there in the waiting room only.
Okay.
Hello, Dash. We can do one thing that you can leave for now and then join because I feel the meeting capacity has reached.
Okay, we could do that. I will just, okay, yeah. Jalab, I had a word with the host and he said
Yeah.
that there is space for participants to join the meeting, but Sahil is not there in the waiting room only. So we are waiting for him to join the waiting room so that he can
Okay,
get
okay.
admitted.
Just call him up directly and just make this.
English, can you get that done?
Yeah, I'm just talking with him right now.
Because it's taking a lot of time right now.
Yeah. Yeah, yeah. Yeah, he did not join to the meeting room.
He got in the waiting room.
Yeah.
Hello, can you hear me? Sorry for the delay.
Okay, Sahil, you can continue, yeah.
You can continue. Just present
Okay,
yourself.
I'll start sharing my screen.
More than 20
All the
teams
best.
we need to judge.
Thank you. Can you see my screen? Hello, can you hear me? Sorry for the
Yes,
delay.
it's all. It's visible.
Okay, Sahil, you can
Yeah,
continue, yeah.
You can continue.
So this is our topic. So we have used deep learning and fetch AI to optimize Aryan's small grocery store owner. So he faces challenges in managing his inventory, and because of limited resources and knowledge, he's he has faced losses because of this, and is on the line of poverty. So for this, we have come up with a solution. So first, we have used the Fetch AI U agents and deep learning model. So Fetch AI U agents are autonomous U agents. So these can be used for interaction between two agents. For example, if there's an agent for at one place and agent at another place, so these two can be grouped together, and they can interact with each other and share information. For example, it's like in cloud server. So in a cloud server, you request information and then you receive information back. So in these, the two agents can simulate this. And the deep learning model is used to forecast the sales for the next month or a week. It is according to the time you set. For example, you train it on the data of multiple weeks and put the time series of weeks, which is the seasonal data. So on that, it is trained. Then it will be able to forecast the the sales for the next week or 2 weeks later. So the implementation of a process of integrating the fetch AI, U agents, and deep learning models. So first we gather data, which uh, which can be ranging from a year to a few months to some weeks, according how deep you want to train the data. Then we make fetch AI U agents. For example, in our case, we have made two agents. One is for the inventory, which stores all the data, which currently holds the amount of uh, amount of all the ingredients that are there. And one is the mainframe, or you can say the admin. So here, the admin and the inventory U agent share data with each other. For example, if there's a transaction that has just happened and an item has been sold, so it needs to be implemented. The changes need to be made in the inventory system. So the agent on its own sends a message to the inventory system agent and tells the inventory system to make its changes. And also, if we want a report, then the main um, can interact with the in the in the system and get all the data. Now, for this is our overview uh, of the model we came up with. So this is the part. This is our main computer, and this is the agent. Uh, so there's interaction between the agent at the inventory and at the admin. So, for example, if you need a report to see if how much ingredients need to be bought for next week. So what this agent does is it predicts the sales for the next week, or at what time you need to predict. On based on that prediction, it will it will first check with the inventory management system, and it will get the data back uh, of the current inventory that the person has. And there will be checking between how much ingredients are needed and how many ingredients are available currently. So if the ingredients are enough to last the amount of time that we have checked the forecast for, there's no need to restock the inventory, or else there is a need to restock the inventory. So yes, so this is as all this is real time inventory tracking. So in many other big companies, it is used. So the problem with this is at start there are many startup costs. For example, setting up all the hardware and the software, and so this can be a little big undertaking for a small shop, but after some time it does pay it off with better management, and it also helps save money. So these is the cost benefit analysis. So so I'll show you the our model now. Yeah. So for this, I have used the profit model, which is by Meta. So what this model does is, first we give it the data for the data's past sales data. It so you give it a daily seasonality. Daily seasonality means it is for every day, and there's an interval width. So it batches the data. So now the model is equals to m dot fit. This is for making and training the model. So as you can see, the model has been trained here. So this is the forecast, which is the prediction that we get. So for example, if you want to see the at this state, so you can see here, you get all these prediction values. For example, at this state, the trend is like this. The lowest value of the predicted price will be this. The highest value of the predicted price is this, and ultimately the predicted price on that day for so the price for example, sorry, the sale will be on that days 15/11, 15/12, sorry. So like this, have we have used the profit to make the model, and I have saved the model here. Now this is the difference between the test set, the actual data that we actually had in the test set, and the predicted data that we got from the model, and this is the difference. Uh, and there it can still be tuned with other parameters, but due to the some time constraint, I was not able to make it more fine tuned. So this is the difference.
So Sahil, why you are squaring this difference? I can see your code, right?
Yes.
Uh,
So uh, actually to get so hold of how your model is performing. So to know how your model is performing, you need to know the difference or the prediction that we get. For example, if you the actual data is 100 and a predicted the model predicts to be 1,000, you can see that there's too much difference between the actual value and the predicted value. This shows that the model is not fine tuned and has a low accuracy. So for checking the accuracy of the model, we see the difference. And there are many other losses also. For example, mean square error loss and other losses that we can use to know this.
okay.
Okay. I guess you just have one more minute. Do you want to add any? Do you want to add up anything?
So the about the UI agents, U agents part. Sorry. So
Hmm.
currently, because of some error, we were not able to completely make our model that I've shown here before. Yeah. So this was our idea that we will make two agents.
Okay.
These are the two agents, and this will be like a whole system. For example, so from one agent there will be uh,
Communication is the another
One
part,
agent
but
can
right
only
now
get
we
the
just have one.
feedback. So it will be automated, and there is no need to query for the person to query it manually.
Okay, okay.
So this makes the whole system very much more convenient. So we were planning on doing this, but due to some library issues, we
Mm-hmm.
were not able to completely do it. But
Okay.
to make it more visually appealing, we have tried to make a GUI. So let me show you a glimpse of that because it is still
Finally,
in the works.
we are running out of time.
Yeah, it's a small, very small implementation, which will just hardly take a few minutes.
Jala, can you please?
Yeah, ma'am. What happened?
Actually, the time is quite up, and we want to move to the next team.
Yeah, so this is a basic GUI
Ma'am,
that
it's
we
okay.
came up with.
One second, Sahil, just a second. Ma'am, two, three teams have already withdrawn. So if
Okay.
they want to present, like take a 2 minutes thing, you can allow them.
Yeah, I'm done. So this is the only thing. This is the last thing that I have to show from my side.
Okay, fine.
Okay.
And I would like to add just one point from my teammate's perspective that after we have successfully
Teams have
implemented and
already
integrated this, future
withdrawn.
solution would be
So if
where
they
we can
want to
integrate
present,
with online servicing. Like right now is only for offline, so that whenever he scans and sends it to someone, automatically his inventory gets managed. But in future, he may even expand this entire business.
Okay.
Okay. Sure. Sure.
Any other
Any
questions?
doubts?
I guess you guys actually did it well, so we didn't had to see the front end though. But it's okay. Sahil, are you presenting?
No, I am done from my side. So this is all the work we have done.
Okay. Good work, guys. Actually, as a team.
Thank you.
Thank you.
thank you so much, team. You all can leave the panel now.
Thank you for your time.
Thank you for the time.
Hello, judges. So the next team which will be coming is 148.
Okay. Okay.
Hello, Advait. Advait, are you there?
Hello.
Yeah, you can start the presentation.
Actually, Aryan has the presentation. Let me just call them.
Sorry.
Give me. My teammate has the presentation. Give me a few minutes.
Oh, so is Aryan your teammate or
Yes, Aryan is my teammate.
okay? Just tell him to join fast because actually we are running a bit
Yes.
late on the schedule and also.
Advait, you were alone, right?
And Advait, you have entered alone because in the sheet which we have, it's showing that you are the sole member in the team. Hello.
Wait, I'll call him.
Yeah, yeah.
Yes, they're joining actually.
Sorry.
Wait, Advait, your team number
Uh,
120.
yes,
No issue.
they are both in the waiting room.
No, you have to leave this meeting room.
Okay.
Your panel is different actually.
Acha, so someone just sent the request to me. That's why.
No, it's okay.
So
Leave it
what
right
time is my panel? Okay, okay,
Leave it.
okay. Thank you.
Hello, Advait.
Hello.
Yeah, so you can start the presentation. Yeah,
Your voice is cracking. Can you repeat again?
you can start the presentation.
All right. Okay. Thank you. So I'll share my screen first. Is my screen visible?
Yeah, yeah.
Okay. So I'm Advait Lad, and like the problem statement which I was working on was inventory management using deep learning. So first I'll go through the PPT and then I'll show you the execution of the code. So initially I'll start the presentation once. Yeah.
Advait, I
So
just want to.
the grocery inventory management system had I've used SKU data.
Yes,
I'll also give
Advait.
data set in. Hello.
Yeah, one of the judges has something to ask you. Can you just take a pause?
Advait,
Yes.
actually, you are the only one from your team.
Yeah, ma'am.
Okay, no worries. Just make sure that you take like 15 minutes of time to cover everything that you want to share with us, right?
Yes, ma'am.
Okay, all the best. Go
Thank
ahead.
you. Yeah. So I'll first share about the data set which I was stating about. 1 second. Yeah. So I've used SKU 110K dataset, which had approximately 12,000 images, in which 1.7 million products were annotated. And this is the the citation from where I have gathered the dataset. And I'll just give you a glimpse of the image as well, like how the images look. 1 second. Yeah. My screen is visible, right?
Yeah, yeah.
Okay. So, these are the basic images which were gathered from some kind of CCTV or people have clicked. So this is one example of how the inventory management system, inventory looks. So yeah. So the basic challenges which I faced initially was there was a lot of noise in data, the angle of clicking the photos are also very different. So, and I had to also annotate the images and exactly see that the products were product classification should be done compartment wise. So I used Make AI Sense, one website for marking the data manually. So these are the applications which I've basically stated at how deep learning can help in inventory optimization and stuff. So this is the dataset information which I showed in the previous PPT. So I'll start with the overall workflow. So the client, the client who is the owner of the inventory,
Then take
will
a 2
have a
minutes
image
thing.
database.
You can allow.
And the manual team checks that is manual annotation is already done by me. Even if the inventory how deep learning can help, can be manually annotated. Later, the data will be shifted to Fire store listener that is on the Firebase, and then we'll be having our deep learning API. And accordingly, the API will work and do the compartment-wise occupancy. That is, it will show that whether the compartments are empty
You
or
can allow.
they are not filled with products, and it will raise alert to the owner that which kind of product has to be reordered or something. Second is count of product. A specific product count needs to be monitored, so that can be also given. And other compartment-wise product information can also be given. And this output will go to a it can go to a CSV, and that can be later transformed into a JSON, and it can be pushed to database also. So I'll be showing the whole database and the UI also. So next is I've given the UI design. So in the I'll show the UI also after this. So in UI, the images will again from the Firebase store, it will go into the three Python modules, that is compartment emptiness, number of product detection, agent alerts, and then this capturing will later go to the database, and this database will be used for product classification as well. So these are the functionalities will again database architecture. I have created two tables in the database, that is compartment info and product info. So compartment info will be having image ID, compartment ID, the emptiness percentage, and compartment number and compartment path, like the path to the image. And the product info will have product ID, its compartment number, and what the product name is. So now like I'll come to the deep learning aspect. So what I have done is I've used YOLO V8 in the backbone, and the YOLO V8 initially uh, detects the borders, that is the compartment diversions, and then it detects the products in the further stage. And these products are then given to the Siamese network. So Siamese from network is a logical neural network implementation in which what we do is, like if a product needs to be searched in any kind of compartment, so it will be given into the pass directory, and there will be a templates like what kind of product, how the product looks, which will need to be searched, and the fail directory will have other products in the compartments. So then the Siamese network will create pairs of positive, positive, that is the product which has to be searched, and the product which is on the compartment, which both match. And whereas in the fail directory, there will be the products which are different. I'll show the whole implementation. This is the deep learning architecture. Initially, the YOLO V8 does the border detector, like border detection, and the compartments are extracted, and then it is saved as compartment 1, 2, 3, 4 for the whole inventory. And in those compartment images, the product detection is used. And these products are then saved into the like item 1, 2, 3 for that respective compartment. And later, the Siamese network uses the genuine pair matching algorithm, which I stated before, and then it classifies the product, and that's like it helps in the product searching. Then this is the benefits, like it helps in reducing overstocking or minimizing product wastage, and it also helps in automating reordering systems. So I'll show you the I'll show you the output first. Yeah. So this is how the emptiness exactly comes. Like if there is any kind of empty space, so this is done by the OpenCV algorithm, and it basically shows that how much compartment emptiness is there. Like you can see here that if there is no product stated, like this is, so you get the emptiness percentage here. And these are the YOLO V8 results, which gives approximately like 96% average precision. I'll skip to the implementation. One second.
So Advait, one question I have, ki how you are counting the product?
Yeah, like I'll show you the whole implementation. One second.
No, I mean the logical explanation means suppose one product is stacked behind the other product, right?
Yeah.
So how can you count that?
So like basically what we like the algorithm is doing that it is only checking for the displayed products for right now, and the compartment width is already given. So if the compartment width is already given, so it approximately like gives you a rough count for that how exactly the products are organized, and the specific count is given.
But you are not calculating the depth, right? Suppose one product is sold now, okay?
Yeah.
So but on the visual perspective, it will be same, right?
Yeah. So like automatically the emptiness will go on increasing in the Excel database, and then you can get a rough percentage. So like if 20% of the compartment is empty, so it will automatically raise the alert that this kind of product needs to be restocked. So it is approximately 80% accurate, but it like helps, like all the CCTV footage data can be easily used by the models for at least getting a rough count of products. So like I'll show.
What products are misplaced?
Yeah. So for that only Siamese network will help. Like first I'll show the implementation, and then I'll show that how Siamese network can easily identify that this product is misplaced or it is not like matching.
Okay, go on.
One second. So suppose like this is a basic. So like this is the in like a image from the CCTV, and you can see like there are products which are not matching here. Like on this side there are Dove shampoos, here it is Degree shampoo. So first, like we can start with the compartment extraction. It is running here, so it will take just 1 minute time. So automatically the compartments are extracted here. So the first YOLO network uses these borders here, and it sorts the compartments from top to bottom. Then here is one emptiness extraction. So emptiness extraction results are basically stored in the directory, where in the output image is test28, like right now the folder which we use. So in this, here are the compartment images, all which were extracted right now. So like there are different products in each compartment. Then here is the emptiness. So here you can see that all the products are being marked using the YOLO. So for Siamese, I have created a test case. One second. Yeah. So now like we have got all the products and like in which are on the display. And here I have like just according to the algorithm only, I've taken 5 images which match to 6 images which match to the Dove shampoo. And 5 images for the degree shampoo, which is totally different. So I've loaded that in the Google Drive notebook, and one second, it will load. So basically, like I'll just explain the code fast. That the zip file has 5 fail images and 6 pass images. So accordingly, like when the code proceeds, you can exactly see like almost we get something. One second, like this, yeah. So this is the original, like this is the query image. This is the image which like these are the sample cases which are present in the compartment. And accordingly, we get approximately 6 into 5, that is 30 pairs of like genuine right pairs and genuine false pairs. So we create the Siamese network. This is the whole code, and we have used the Euclidean distance for matching, like matching the white features from the Dove shampoo and blue shampoo and blue component from the degree shampoo. And it is like only for 15 epochs, which takes approximately only 1 minute. So like even if the product packaging is changed, you can use the Siamese network for identifying the product. And I'll show the searching agent for the product search key.
Hello, Advait. Sorry to cut you, but like, please wrap it up a little bit quick.
Yeah, it's only the last part.
Yeah.
Yeah, so like we get the whole data set and exactly how it is going to like all the products in the database, and then this is the last part. Like I just wanted to show the whole execution. And here is the last product search. Like if the input is given that if you want to find the Dove shampoo, so like it is running in the background. 1 second will take. So actually, I wanted to like this product search. I wanted to put on the Flex AI agent. That is the Delta part here. Once again, but actually it was not allowed for like it is in the beta format. So currently it is not allowed for like outsider users. So, like I've created a basic agent in my command prompt window only. So like for each compartment, the model iterates, and basically you can like it is comparing all the products. It is searching for the products, and we'll get the result in last 1 minute. Here is compartment 3. So like in compartment 3, we had the Dove product. This is the query image.
We'll do it 2 minutes more and then we'll stop you there.
Yeah, okay. It won't take, it's like last compartment. It won't take much time. Like till then, judges, do you have any questions?
No, Dwight, I guess we are good from our end, and you had put in great efforts for this whole execution and everything.
Thank you, ma'am.
Yeah, it is good.
Advait, just I have one question. Which version of YOLO you have used?
V8. Actually, the output is here, so I just wanted to say like you can see that the Dove product is specifically present in 3, 4, and 5. So here, like the query image, it gives the all the compartments in which the product is given, and later this is stored in the JSON file, which JSON goes to the delta beta thing, like on the Flex AI, and from there, like if the client wants to search any product in any compartment, so from here it can directly give it to the agent, and then agent can reciprocate. So like I tried to build that delta Flex AI agent thing, but like it was not allowed for third party people. So I've just created a service here, like in my CMD, because it had a pip package, UI agents.
Okay. Oh. Good, Advait. Yeah.
Thank you.
Okay, thank you so much, Advait. You can leave now. Judges, this was team 148. We'll be moving to team 152. Hello, can you hear me?
Yes, Jalak, you are.
Yeah.
Okay, fine.
Hello, Nisab.
Yeah, hello.
Hello, Yash.
Hello.
Hello,
Hi, you
judges.
guys.
This is team 152. They'll be starting now.
Hello, team. All the
Hello.
best.
Thank you.
Yeah.
Nisar will be the one who's screen sharing.
Yeah, just a second.
After the presentations, now we'll go ahead.
I'm sharing my screen. Can you see it?
Yes.
Okay. Yeah.
So hello, judges. With the team Fetch Up, we consist of Krishpilla, Nasarkada, and Yashra. So the solution we came up with the problem statement was we'll be harnessing Fetch AI's U agents. We created a decentralized network by for seamless data exchange, focusing on critical attributes like restocking quantity. By introducing neural network models, we plan to maximize the profitability for Aryan's business. The technologies we've used is Fresh AI U agents, TensorFlow, Fast APIs, Scikit-learn, Pandas, and NumPy, obviously, and AstroJS. Our project works threefold. So first, there is U agents communication. Then there's the deep learning model, and then there's the front end part of it, which the store clerks, Aryan, and people managing the stock themselves will be interacting with. After that, we started synthesizing the data set itself because there were no data sets available. That'll be covered by Nisar right now.
Yeah. Am I audible?
Yes, you are.
Yeah, okay. So for synthesizing the data set, we basically needed one CSV that we took from like 1st Jan to 31st December. And on each day, we just took like 5 products. And the CSV just contained the value of stock for each product on that day. But we could not make it completely random because then we would not be able to, apply a deep learning model and train it on that data set. And we could not also have it follow some kind of a pattern because then that would lead to overfitting because it's a synthetic data set, it's not an actual data set. So we decided to use sine waves with offsets for each products, and we also integrated some conditions, like if the stock is 0 for 2 consecutive days, then the stock will be equal to the restock threshold. And then during summer we added random noise for each of the products to stimulate seasonal changes in demand. So these are the graphs. So the x-axis is basically the date and the y-axis is the stock. So as you can see, each of the products follow some kind of a sine wave with like variations in them. So this synthetic data set basically provided us with random data that followed some kind of a pattern, so that we could actually apply a deep learning model and not overfit the model. Yeah, Yash, you can continue.
I think this part will be covered by Krish.
Am I audible?
Yes.
Okay, so basically the UI that the clothes or Aryan would be interacting with needed to be very user friendly so that everything that the data that was portrayed out there was very clear. So we started with a homepage, as you can see. So the homepage consisted of dates. So like you can see the inventory details, on dates, like what business was done on each date. And as you change dates, you can. For now, we just use 3 dates. And as you click in review annual statistics, it generates a yearly model which gives like a summary of how your year has been business wise and how to improve basically in the coming years. Moving on to the sidebar, we have a predict model. A predict model basically it sends out push notifications. So when a product goes out of stock, we it sends out a notification sensing the algorithm that it will go out in 3 days. Taking in the data from the past weeks, there's a price change. So if there's a high demand and the stock goes down very quickly, the price changes. Like there's a price hike that occurs in the product. Similarly, if there is no demand for the product, that is like the inventory has no changes for 3 consecutive days, the price also stoops down to match the supply and demand curve. There's an expiry alert, so as soon as the shelf life gets closer, right? So as there are 3 days, as soon as there's a 3 days window, 3 day window to expiry, there's an alert that is sent out to the app saying that there are products that will expire in 3 days. And as soon as we restock, there is a restock alert that you can use as history to see when and where have you been restocking your products. And these are stats, so like individual product stats to see which product has been producing how much profit each month. And if you want to reorder, you can just click on the button down there, and it will be redirected to future. As a future prospect, it will be redirected to whichever site you use to order stock for your inventory. So this is basically it is all of this is basically taken from Fetch AI. All the stats that have been here. Moving on.
So other than this, we'll be showing you the.
Yeah.
So we'll be covering the deep learning model and the actual working of the Fetch AI agents itself. The Fetch AI agents part will be taken by Nisarg, and I'll be explaining how the deep learning model itself works. So Nisarg, you can get it.
Yeah. So basically, for Fetch AI U agents, we have two. I'll just run the scripts. We have two agents that are communicating over one protocol. So we created an inventory protocol that is shared by the restock agent for now and the inventory agent. So the inventory agent is basically responsible to actually carry out the transactions of changing the values in the storage. So U agents come with their own context, and each context has its own storage. Uh, unfortunately we could not figure out how multiple agents can use the same storage, because by default each agent have their own context and own storage. So for now, for the hackathon, we just simulated a shared storage. But basically we have two agents. One is the restock agent, one is the inventory agent. The inventory agent actually carries out the transactions of changing the database, and the other agents, like for example the restock agent, will just communicate with the inventory agent, and they'll request changes and receive changes, or rather receive responses for their changes. So for this particular example, the restock agent just runs 24/7, and whenever a particular product is close to its shelf life, or when the stock value is close to the minimum threshold value, it will basically request the inventory agent for a restock and update the values in the database. The other part of our okay, I'm not able to type here. No, it's wrong. Okay, I'll just explain it. I'm not able to access my keyboard. Yeah. So the other part of the U agents was our we just simulated basically the inventory actually interacting. Sorry. Meanwhile, while I figure out my keyboard issues, Yash, you can take over the deep learning part.
Yeah, can you just open the deep learning code if possible?
Yeah, it's here.
And the terminal part of it. And the terminal, yeah, running. Can you just run it once for the?
Yeah, I'll need to connect my other keyboard. Wait. Till that time, just explain the code.
Okay, so the deep learning model that we've used is a simple neural network. The thing is, we were going for something like an LSTM or a time shared model, but we realized there's sequential dependency required in LSTM, and there's also a temporal aspect needed, none of which are important in our aspect. So we use a simple neural network which has 128 neurons on the first hidden layer. Then there are dropout layers which avoid help us mitigate overfitting, and use the ReLU function to mitigate vanishing gradients. At the same time, we've used a dropout rate of around 0.3 for the dropout layers, and we've also used Adam as an optimizer. So the Adam optimizer would allow us to prevent. I'm sorry, one sec. incorporate momentum and allowing it to keep moving in the right direction when the gradients get smaller and smaller throughout the neural network. Other than that, with the training parameters we've used is a 100 epoch model with a batch size of 32, and we use a standard scaler to standardize the input features.
Yeah, do you want me to run a query?
Yeah.
Yeah. So basically, we have also used Fast API to act as a kind of like a communication, app between our deep learning model and our U agents and our front end. So the front end does not interact with the Fast API directly. That will be handled. The front end only interacts with the U agents, and the U agents interact with the Fast API. But I'll just simulate query basically. So on this terminal, basically, I have my Fast API app running on port 8000, and the URL or the API endpoint that will be created will look something like this, which will have query parameters like the product name, the date, the stock, restock threshold, etc. And here, so the Fast API basically calls the function from the deep learning model, and it returns the predicted reorder quantity. So this particular model, as of now, just predicts how much or what quantity you should be reordering based on your past trends.
So if you can look at it in the query itself, it states, so in the query, if you look on the second line, it says stock is equal to 82 and the restock threshold is 30. So there's not a huge reorder quantity required. So there's a smaller reorder quantity of 2. So according to that, our model works in, it predicts reorder quantities. In future scope, we'll also have things like, so right now we've added seasonal changes, like we have added noise in our dataset, but as it is a synthetic dataset, we couldn't completely uh, work on all aspects of the prediction model, like the things you mentioned, like discount rates. So if there is a product which has a lower shelf life, if there are like 20 units of product one left, which have a smaller shelf life left, there'll be an instant 20% discount because the product will just go rotten instead. So those things would be something we would cover in future scope, but we couldn't right now because of time constraint and the data set.
So yes, how much the accuracy you are getting?
So the accuracy, sir, as we have spoken, it's a synthetic data set. We weren't getting more than 45% accuracy because the point is either we can have it overfit and we'll get an amazing accuracy, which will be pointless. We can show a direct relation, but that completely deviates from the point of a neural network itself. If we just set like a 1:1 or a 1:2 type of relation, so the accuracy isn't that great because
Okay.
we ourselves are synthesized in data set.
Okay. Have you tried any other datasets?
We couldn't find any specific data sets for this model itself. That's why I think you'll see a lot of people who are making up their own data sets because we looked on Kaggle for a while. We spent around 2 hours researching. We also looked on data.world. We couldn't find any data sets that match this scenario specifically
Okay.
because general data sets have like a chain like Big Bazaar, which has multiple cities. That is not applicable to a small store like Aryans.
Okay, no worries.
Also, I would just like to add that while creating the synthetic data set, we did not have any restriction on the number of or the count of reorders because in the problem statement, as it was mentioned, that Aryan's business is not doing well. Whereas in the training model, we have implemented some kind of condition in a way wherein it'll aim to lower the number of times that it reorders. So the frequency of the reorder quantity being 0 or the predicted reorder quantity being 0 is slightly higher, and that is to reduce reorder cost because the business also incurs cost while reordering, carriage costs, etc. And that's why we also will have like the summary will show how much was spent in reordering, just reordering
Okay.
stocks.
I got my answers too.
Okay, and one more question: why you have not used the LSTM model?
Sir, something like LSTM requires sequential dependency, which is not really important in our things. Like something like if you have a time series prediction or natural language processing, LSTM would have made more sense. But this is a very simple data set that we ourselves synthesized. So a long short-term memory model didn't make sense. So we went to the simple feed-forward neural network. We also thought of implementing different things like I don't know, like a Euler network, but it didn't make sense either
Okay.
because we have ourselves made the data set and it's rather simplistic. It's not overly complicated.
And we made it simplistic because assuming that in the problem statement it is mentioned that Aryans is a family owned grocery store, so they would also not have that, like
Sophisticated equipment of
sophisticated, yeah, of measuring like data or like just maintaining that database manually.
So for how many days the data was there?
it's a year, 365 days, and there
I'll
are
just
five
show.
products that are overall tracked. You can
I'll
open
just
the CSV if you need.
yeah, I'll just open the CSV. Yeah, so this is what the CSV basically looks like.
And is it like, have you guys, like, is it, how have you synthesized it?
Yeah, so I'll just show that part also. Yeah, it's here. So basically, for each product, we just took 5 products, and for each product, we just assigned categories statically. This was just to ensure that the products don't randomize a category. So like product one ka category will remain category one for the entire year. That won't change, right? Then we have restock thresholds. So they are somewhat randomized. This is assuming changes in demand. So seasonal demand or just random changes in demand. So accordingly, your restock thresholds would also, change. However, later we then decided to just make those static for each product because we were not getting a good enough data set. Then shelf life also, this was also made static later. So all of these codes just get a random integer and then set it fixed for the entire year. And offsets also same. So offsets were required because we didn't want every product to have basically the same trend throughout the year. Start of the year, the stock quantity was reducing, and the end of the year it was increasing. So we just use offsets because we are using a sine wave to generate the noise. And yeah, so here we are generating, fake demand increase during summer and adding noise for that. And we had some other conditions as well, like if yeah, so this was something that we were going to implement. That was dynamic pricing, but we didn't have enough time. So based on the stock level and the shelf life, we could change the pricing. So for example, if we have a lot of stock left and the most of the stock is about to expire, we can give discounts and change the pricing of that particular product.
Sorry
But
to interrupt, Nisarg,
yeah,
in between. Actually, I just wanted to ask the team that rather than creating your own data set, generating and synthesizing it, uh, what is the main reason of creating your own data set rather than using some data set already available, making it quite worthy enough for our problem statement, and
We would have
choosing.
been very happy if there was a data set. We couldn't find one personally from the extensive research the three of us did. We also asked the organizing team themselves, and they didn't have any concrete answers on what data set specifically to
Okay.
use. So we ended up going with this approach, which worked well for us, I think.
Okay, fine. Yeah, so can you, so we can wrap it up, right? Is it anything left from your end, guys?
Not really. We
not
just wanted
really.
to show you the U agents part, the keyboard disconnector, so you can see the bottom
Yeah.
left of the screen,
Okay, yeah,
the
yeah.
inventory itself. Yeah.
Actually, that is a quite good effort from your end, guys.
Thank you.
And yeah, really
Are there any
appreciate.
other questions?
No, I guess we are done from our end.
Thank you.
Thank you so much, team. You all can leave, I guess.
Thank you, judges.
Judges, this was team 152. We'll be moving to team 151.
Which team? Janvi, Jalak, can you please repeat which team?
Hello, yeah, Darsh, tell me.
Can you repeat which team?
151.
Okay.
This was team 152. We'll be having next team 151.
Hello.
Hello, Mitesh. So, hello, judges. This
Yeah.
is Team 151, Mitesh. We will be starting the presentation.
So am I audible?
Yes, yes, you're audible,
Yes,
Mitesh.
Nitesh.
Okay. So is my screen visible? Hello.
Yes, it's visible.
Yeah, yeah.
So good afternoon, everyone. So I have my name is Mitesh Madan. I'm from Team 151. Should I also start a video also? Yeah. Or
Yeah, that would be appreciated. Thank you.
yeah, yeah. So my name is Mitesh Madan, and I'm from Team 151. For the given problem statement, I have created a smart inventory management system. So the main things I have features I have in my application is that I have inventory management system which is easy to use. So the one of the main thing which I saw in the problem statement that the Aryan was not able to manage and was not able to manage the inventory, and also he was not able to check or not able to manage whenever he was facing untimely orders or something. So what I have created is a two things, inventory and order section. So in inventory he can add an item. For example, he can set, for example, in this example I have added bananas. He can also set the item price, and I have given the freedom of choosing whatever unit he wants, and he can also put the stock for the stock which he has in the inventory. So I have given an option to also edit the stock whenever he receives a specific order, whenever he receives an inventory. So he can update the inventory. Also, he can add multiple items. So second part is the order management system which I have created, where he can specifically place an order and also get a list of all the orders which he has received. And the main third part for there is the smart alert system. So whenever our system finds out that our stock is not sufficient for the kind of orders which we are receiving, then it will send us a message to the user. As you can see in the bottom right corner, where the message is sent saying that there is a low stock alert and the items are running low for bananas and apples. So now in the next slide, I will explain the algorithm for this. So in this thing is that whenever he's putting an item in the inventory, I'm giving him the four options: the name, price, stock, and fourth one is the alert, which he can select. For example, for the given example in the item image, I have added the name as Chiku. Then currently I'm holding 20 items, 20 units for Chiku, and I have also giving a specific input for alert. So whenever the Chiku goes below 5, then alert would be sent that you don't have sufficient Chikus available in the inventory. So buy new Chikus. So and also the thing is that the alert threshold is not sufficient. So it should be smart enough that it should understand the previous orders and check whether that if the same trend continues. For example, I assume that it takes 1 day to restock the items. So what it will do is that it will check orders of last 2 days, and it will check whether receive like 40 if I've sold like 40 chikus in last 2 days, if that same trend continues for next 2 days, whether I will be able to fulfill the order. So I've written an algorithm for that. So for that, I'm using Fetch AI's U agent. It will run each day. At the end of every day, it will go through all the inventories and all the orders. It will check how many items were sold in last 2 days, and if that same trend continues, then whether we'll be able to fulfill the orders. So it will, if we are not able to send the order, then it will send the alert to the user saying that you don't have a specific item, you don't have sufficient stock for that item. So should I show the working of the project or hello?
So just one thing. So have you used deep learning over here?
So specifically, I guess I have written a normal algorithm for understanding like past 2 days and because I felt that deep learning will be like too overkill for this situation. Using algorithms like LSTM will be like too overkill, but not they. And because the as we saw from the problem statement is that the Aryan is a small grocery shop. Aryan owns a small grocery shop, so he might not have a lot of inventory. So there won't be a need for understanding a lot huge demand,
Yeah,
I
but
guess.
we need to see the trend, right? Based on seasons, based on the weather, which product is getting sold more or less.
I guess I haven't used a specific algorithm for checking the trend.
Okay, so can you just
Okay.
brief us that what is your scope of this algorithm? That it could predict, or it could predict based only on the stock available right now, right?
Yeah. So it will check so what main thing which I'm doing is that I am assuming that it takes 1 day to restock the item. So I can in future enhancement I can put an item. For example, for Chiku, I can give a allow user to put how many days it takes to restock that item, and according to that I can, for example, it takes like 4 days to restock the item. Then what I can do is that I will see the last 5 days, 5 orders of last 5 days, and understand whether if that same trend continues, that whether I will be able to solve the fulfill the demand.
Okay, okay, okay. Got it.
Yeah, you
Carry on.
can go ahead with demo. Yeah.
So should I show the working like something, or
Yeah, yeah, yeah.
Yeah, sure,
Go ahead.
sure.
so this is the main inventory system. This is the main where you can edit a specific item. Then also giving the freedom to add a new item. For example, here, if you add Chiku, then Chiku will be added into a system. Then if I go into order system, what I've done is that I've created a small point of sale system where he can place a specific order. For example, he sends buys 3 quantities of bananas, add to order. Then I can select Chiku. Then the order will be placed. And as you can see, the order is placed in the order system. So at the end of every day, the fetch AI's U agent will go through all the orders and understand how many items were sold and whether that items are sufficient, whether we have sufficient stock in the items, sufficient stock in the inventory. So this is the main algorithm which I have written. So this is the main, as you can see, as I'm highlighting, this is the main thing which I'm written for the. So I'm just going checking whether the stock is less than the alert stock, like the threshold which I've set while adding the item. Then it will send an alert. And second thing is that, for example, in this, I have assumed that it only that we are able to restock that item in 1 day. Then that's why I'm checking for 2 days further, just to be more careful. So then what I'm doing is that I'm checking the orders of last 2 days and understanding how many items were sold, how many units of that specific item were sold in last 2 days, and understanding if that same trend continues, then whether I will be able to fulfill the order. For example, in this is the main thing. Stock less than alert stock is more than 2 days of sales. If we find out, if the algorithm finds out that it is not sufficient, then it will send an alert. So this is the main application. The rest of the things is just APIs. First, uh, when it comes to technologies which I have used, for front end I have used React.js. For database I have used Firebase. For APIs and server I use Flask AI. And for alert system I have used for sending messages I have used Twilio API.
Okay. Okay. Mhm.
So if you have any specific doubt, then you can ask.
What will be the future scope of this app? I mean, if you want to improve something, what you can improve?
Yeah, what I can do is that I can get use synthetic data to understand, not synthetic data, but what I can do is I can, if I get a API where if I get how many items were sold in last 3 years, then I can use algorithms like LSTM to understand a specific pattern and from that algorithm. For just for this use this problem statement, I've found out that this will be enough for understanding a small scale business. Or if I have large scale business like Reliance, then it will be much better if I use a large deep learning algorithm which understands a specific pattern or specific seasons, like like strawberries are sold in specific seasons and something seasonal items or in that case.
But get the data online, right? I mean, for this solution as well.
Sorry, can you repeat? Pardon?
You might get the data, right? Just like you currently you assume for last 2 days, right?
Yeah.
But you could have implemented the solution deep learning based, or the you can get the data from the internet or Kaggle somewhere, right?
Definitely I could have done, but I guess.
Okay. So yeah, so this is from my side. Jarvi, you have anything to ask?
No, actually, I guess, Mitij, as of now, you have implemented it good. But I guess you could have done it better
Yeah.
using deep learning, because that was like advanced level for what we are supposed to judge you. Okay.
Yeah.
And yes, you can use data sets, and also you may have used some, because right now, see, what's the problem with your statement is you can predict by what data you have currently, okay, but you can't forecast it.
Yeah.
So main issue is about the forecasting. That is what the whole concept is all about, that how we could restock data based on the next necessity or the next availability according to the market trends. So that's it. Yeah. Good efforts though, Mitej.
Thank you.
Yeah.
Thank you so much,
Thank you,
Mitej.
Mitej. You can leave now.
Okay, thank you.
Judges, this was team number 151. We'll be moving to team number 149.
So I have written so I have written
Tilak, how many more teams do we have now?
Ma'am, actually, 5 of them have already quit the competition. So don't worry, we'll catch up on time. And how many more teams we have, I'll let you know. We have like 8 of them, ma'am.
Sorry, couldn't hear you.
8 of them, 8 of them.
8. Okay.
Yeah.
So every year this event is online, right, Jalak?
Yes, ma'am.
Okay. And you guys follow the same routine throughout?
Yes, ma'am. Actually, last 2 years it was 24 hours hackathon. This year we've made it to 18 hours hackathon.
Okay, okay.
Yeah.
So this coding and all is done in the institute itself, or is it like you can do it from your place or something like that?
So no, ma'am. So it's like you will have to like do it from your place online. We don't host the event in the college.
Okay. Okay.
Hello, Aniket.
Hello. Hello.
Yeah, is your full team here? Is your full team here?
Now.
You all can start the presentation then. You all can share it.
Just a minute. So, our group name is JVK and we are number 149. I'll start with the solution. So,
Guys, sorry to interrupt you, but just
Yeah.
that please try to wrap it up in 10 minutes.
Okay, sure, we'll try.
Yeah.
Okay, so mainly there are two major issues, inventory management issue and untimely orders. So Aryan's grocery store has been struggling with poor inventory management, resulting in empty shelves and stockouts of essential items. Now another one was untimely orders. So whenever the order is placed at suppose the store is about to close or something like that, so the product becomes unavailable at that time. These things led to customer dissatisfaction. Now, how do we approach to a solution? First of all, we uh, went to Kaggle to find our data set. There we also met the model we were going to use, that was uh, LSMT, long short-term memory. So when we found the data set, we performed some EDA, that is exploratory data analysis on it, and we found some patterns in it. The pattern was that on holidays, the sale actually grew, and the sales were highest in December. So these were the graphs that we got by analyzing the data set. The holiday sales are greater than those of non-holiday. Now the model that was used is LSMT. It as the name suggests, it long short-term memory. It was made to uh, actually work with time. Okay, it remembers past elements in the sequence, such as sentence songs and stock prices. It understands context and relationships between them, and the long-term memory term learns connection between distinct elements unlike any regular RNN, recurrent neural network. Let's look at the implementation. So Roel will share the screen for that.
Rohan, you are on mute.
Rohan, your mic is off. Rohan.
Hello, Rohan. Other members of the team can take it ahead, please.
Hello, am I audible?
Yeah, you can.
So this is the agent file which we made using fetch.ai. We are importing all the necessary libraries here, and we are loading the model which will be explained by Aniket. And for creating the model, we are using the library pickle. And for connectivity and getting the data, we are using MongoDB as our database. So here we are creating instance of the client and fetching the data from the database. And we are creating two agents named Aryan and Inventory. So on startup, when the event is loaded up, we send a message to the agent Inventory uh, about the prompt which has been entered. So every agent has the function on message which defines what the agent will do when he receives message from another agent. So whenever the agent Aryan receives a message, he will just log that in the console. And whenever inventory agent receives a message, it will check whether the message is S. If it is S, then it will print recent 5 sale records in the recent order. Next, it will check whether the message provided is P. P will be used for predicting the sales of a particular day. In this section, we have incorporated the model which we have built to predict the sales of a particular day. This is the code for that. And last one is for checking the refill of the if whether when the stock or the sale is exponentially growing, then we will advise the agent Aryan to fill up the stocks of the groceries. And here we are using Bureau to add both the agents together, and then we are running the Bureau. So let's just see the program in action.
Guys, wrap it up in next 2 minutes.
So this is the main menu. We can enter some prompts to predict. So when I enter P, it will ask the date of which I want to predict the sales. Let's say 14. Week 7. The data set we are using is of old times. And we can provide the family to which the grocery belongs. So let's try dairy. and whether the day will be a holiday or not. As we have seen during holidays, the sales increases. This is this is as result. Sale of family dairy will be 37.5. So according to the prediction we get, we advise uh, whether we should increase the stock of this particular item or not. That's it.
So you have not automated that step. Okay, once we predicted the item like 37 item. So have you not automated the step with the Fetch AI agent so that you can send some message to fulfill the inventory?
No, we were unable to do that.
Okay. And one more thing, can you scroll the code bit above? Okay,
Which
so
section?
yeah. So I was asking about the data set. So how you get the data set? I mean, you have created by your own or you fetched it somewhere from online source?
We downloaded it from online.
Okay. So have you pre-processed the data?
Actually, the model work was done by Aniket. So Aniket will answer that.
Hello.
Yeah.
Hello, sir. Yes, the data was pre-processed before feeding to the our LSTM model, and we have used two layers for in our models. The first one is our LSTM. We know it's a great library for regression purposes or prediction purposes. The second one is a dense layer which consists of a number of neurons. And talking about pre-processing and EDA, sir, we did some EDA for removing for handling the missing values, and there were sir, when we got this data set, the data set contains a lot of family of the items which aren't present normally in grocery stores. Like the data set consisted of items like slippers, flip flop, clothes. These are not the ones that we use that are kept in grocery store. So we clip the data set and use the subset of the data set which just contain the groceries. And apart from that, we did some feature engineering, like the data set that we got from Kaggle. It contained the date as a single column. We broke it down to year, month, day of the week in because it was easier to feed to our model, and it gave us good accuracy.
What is the
Accuracy of this model,
Yeah.
ma'am, it was around 86.
Okay.
So you have used the LSTM model, right?
Yes.
For prediction or training both, right?
Sorry, sir, I couldn't hear you.
I mean, you have trained the model on LSTM, right?
Yeah, I mean, the model is sequential model, but we have added a LSTM layer in it.
Okay. Is means that layer is that code is present here, or
Yeah, sir, it's present. Just a minute, sir. I need to join with my another device. Can I do that now?
Aniket, can you just do it on this one only, because then we'll not be able to let you in from that device also.
okay, it's fine, it's fine. No
Okay,
issue.
just a minute.
And do you guys have any UI design for this?
No.
Okay, no worries.
Just a minute.
Guys, I guess it's fine. No worries.
Actually, this is the code, but it will not work on my PC because I don't have the
Yeah, no
CSV
worries. No
files.
worries. We
You
understand
can
it.
go through this. If you want.
Yeah, that's okay, Rohan. We got your point. We can wrap it up, I guess. Do you have any questions from your end, Shubham?
No. It's fine.
Yeah, yeah. Good work,
Team
team.
one, team 149. I guess you're done with the presentation. You can leave now. Thank you so much.
Thank you.
Thank you.
Thank you.
Judges, this was team 149. Next team will be 156.
Hello, team 156. Are you there? Are you guys there?
Yeah, we're there.
See, you guys have typically 10 minutes there. Just wrap it up inside that, okay? Okay, guys
Okay,
can
no
start here.
worries. Yeah, no worries. Do we share screen and start now?
Yeah, you can start. Judges,
Yes.
they are starting the
Yeah.
presentation.
All the best.
Okay. Okay. So we'll start with the presentation. Okay. So we created an inventory management system using LSTM network along with integrating it with Fetch AI's autonomous micro agents. Okay. So first we'll talk about the problem statement and how we approach it and its summaries and challenges before we move on to our solutions. So in this case, the problem statement is, of course, Arden is the owner of a family-owned small grocery store. He does not have access to a lot, and when he was young, he saw that his family faced poor inventory management and untimely food orders, which led to blank periods where the family could have been making money, but due to out-of-stock inventory, his family lost out on opportunities to make money. And due to this cycle, it unfortunately led to a decline in business and ultimately led him to poverty. And in this case, we use this solution with Fetch AI to help him out with this grocery store issue. Okay. So, of course, the problem is inefficient manual inventory management, the reactive restocking, which took too much time, and difficulty in accurately predicting demand as it changed. So, the challenges we, of course, face for balancing supply and demand to ensure at the same time there's enough supply available to meet all demand, but at the same time not to overorder, which would lead to loss and expired products. Okay. So now to start on the solution, we were looking for data sets and we found this data set which contained over 1 year worth of invoices. Okay, from the year 1st December 2010 to December 2011. This contained over 100,000 entries of single items with different quantities on purchase on different dates between this time period. Using data mining techniques, we sorted them all by the time they were purchased. We grouped them all together by the product IDs, and then we summed up their quantities across a span of months. Thus, we formed our own time periods to get our own data from this data set. So in this case, as you can see, we have around 76 time periods. In our case, we took each time period as a span of 5 days worth of sales per product. And this way we could form a 700 column long, each column representing an individual product with over 76 rows, which represent the period of sales in a specific time period, from time period 1 to 76. So now we approach the idea after a lot of brainstorming. We realized the best way to approach this idea would be to use a LSTM network mixed with the agent architecture to ensure that the LSTM network in this case, which would help us constantly predict the next time period's data. So as example, use a basic LSTM network with 40 layers along with a dense network to connect it all back. We fed it as a sequence of 3 time periods at a time to ensure the model was trained perfectly, and we use a min-max scaler to normalize all the data and fit in any variations and variances. Using the LSTM model, we could predict the 4 days data and train it on the mean square error loss. And we eventually built a model that can predict the 76 time periods data. So now, of course, we integrated this U agents as well. So as you can see, I'll explain the screenshots. We start sequentially when the customer interacts with the customer bot. So the users place an order for 5 pencils by entering the name and quantity the product wants. Then the U agent will check its own storage file. The store U agent will check its own storage file, and it will check the quantity of pencils currently available. If there are sufficiently available pencils, the U agent will place an order for 5 pencils, thus subtracting the quantity from its stock and sending a message back to the customer bot that pencils have been delivered. Then, using the LSTM, the U agent will first calculate and check by training the model based on pencils and its past data to predict how many pencils will be needed to be sold for the next time period. And in this case, you can see for the next 5 days, the pencils needed to be sold will be 292. So the user agent will check its quantity and see that there is only 110 pencils left. Thus, it will use an algorithm to subtract which is then simplified, will basically subtract the updated quantity, which is lesser than the required quantity for next week, and add to it a buffer unit based on its previous demand, and place an order by contacting the warehouse and sending the money and the request and the invoice and sending the request and the quantity to the warehouse. The warehouse will then check its own inventory and send a stock confirm message back to the user, back to the store. So this way, these three micro agents will keep interacting with each other, such that it will always be checking by predicting the next time period's demand to accurately gauge how much stock will be needed and ensuring it on time which will lead to no delays between orders, thus having the complete inventory space utilized perfectly. So we use the warehouse for validation, validating the request. The store, of course, will have not only its own JSON file, which will contain the storage limits of every single item that is available, but along with it, it will also have the updates progress that the warehouse has sent them. So using this, and this on the side is example of how the store's data looks, with each product ID representing a certain SKU, which is sold at the grocery store, and the inventory cost, then the inventory stock it has currently. So to summarize, we use three user agents, being the customer that interacts directly with the customer and can take in its inputs in the form of text that converts it to a command to be sent to the store, which will then ship the items back to the customer, and if needed, also send an order to the warehouse to send more stock. The LSTM model will be used to demand prediction for the next time period, along with gauge how much stock is needed to ensure orders aren't overstocked or understocked. And based on this, it will automatically restock. And since it's a real-time system, the next weeks and the next time periods and the next time periods data, if available, can constantly be added, thus building the model as we go on if we add more data. So again, like I said, breakdown customer will handle the purchase request, storage and manages inventory, handles purchase and triggers the restocking, and warehouse will receive and fulfill restock requests. We use LSTM for prediction of demands, and we use restocking based on triggers along with certain parameters which we set to ensure the level never falls too low, and a certain buffer parameter which is tuned to each product. So the benefits, of course, will be that there won't be any blank spaces in which the products will be unavailable when they were needed, which will lead to maximizing profit. But at the same time, products won't be over-ordered, thus leading to loss if products expire or spoil. There'll be reduced costs simply because of the minimized storage required, such that we'll always have what we need, but not too much. And simply because of its nature of storing its own data along with its past interactions and history, it will be able to build on itself and thus improve over time. And of course, since this is a simple inventory management system adapted like this, we'll be able to use it with various businesses, not just grocery stores, but also most other data management supplies in which they have enough data to build this initial model. Thank you. Yeah.
So you have some demo for it? I mean,
Yeah, we can run our code. If you want, you can share our screen and run our code. Does that work? Can we share our screen and run our code so we can show you how it works? Okay.
Yeah, sure.
Do you guys have any UI design or anything like that?
We use the simple text input on Python because we concentrated mostly on this.
Okay.
So if you can see our original products.csv file, this is after pre-processing. So after pre-processing, this is what a file looks like. Separate. Let's have my state since it's not showing here. Yeah. Okay. So as you can see, okay, this over here is so this is the data after we finish transposing it and making it into columns. And this is our original data. Okay. So this is the transpose data. And I think the original data open. Yeah, this is the original data. So they were framed by invoice date along with the description of the order and stock code, which we then transformed into this format with each row being a specific time period and each column being its own data set for that specific product. Then to show you the code.
Sorry guys, just to tell you one, like you guys are only 1 minute left. You need to paste
Yeah,
that
okay.
up.
Okay. So this is the code. Okay. So as we can see, we uploaded the CSV file. Okay. Then we did the columns using iLog, and we made some classes for the user agents to interact with. Then we created three agents: a store agent, custom agent, and warehouse agent. And then using the inventory management system of the store agent itself, we set a startup task so that every time on startup, it will check whether the agent is currently running. And if it's not running, that won't work. But if it's running, it will run. Okay. In this case, first it will now read the CSV file and randomly generate the initial starting values of the inventory, since we didn't have real time data to generate it based on. So we randomly generate the starting inventory values for each product in the stock. Then we iterate through all the product IDs in the total list of product IDs, and we get the inventory level and store it in the .json file. Okay. Then we print the full
Yeah,
table,
this
which will
is
show in
fine.
the code. Then
This is fine. Can you run the code if
yeah.
possible?
Okay. Yeah. One sec. We'll run it. So the pip environment is not working, so I'm asking one of my team members to share it because the pip env didn't get installed correctly on my device. He'll share it in just a second. Wait, I'll stop sharing.
So, meanwhile, can you? Yeah.
One sec. I can't.
Guys, done, right? Team 156.
Yeah, so I'm sharing the screen right now for the code. Can you see my screen?
Yeah.
Yeah, okay. Just a second. Just a second. Yeah, so as you can see, this is our data set. And now I will enter a demo quantity required for my purchase. So suppose if I enter the quantity 5 and then the product ID. So this is an already existing product ID in my data set. So I'm just entering it for this sample. And here you can see the initialization of our inventory. So these are the random generated values for the initialization of our inventory. And then we start with our training for our architecture.
So, suppose you have already trained model, right? Can you predict it? Yeah, now it's fine.
Could you repeat again?
Means can you forecast something ki how much
Yeah,
data
right
is
here.
required?
So if you can see.
Yeah.
So can you see my cursor where I'm placing the cursor?
Okay.
Yeah, so as you can see, our predicted stock demand for the next 5 days is 231. And it says that restock is needed for this ID because there was understock for this product ID.
You are training the data on every query, something like this.
Okay, am I audible? Yeah, so what we're doing is basically we have a data set of daily invoices, right? So what we want to do, we want to predict the next demand for the next 5 days. So what we did with our daily data set is we kind of grouped 5 days together,
and that is one block. Okay, so we summed all the quantity, and that is our one block. Okay, so and we've taken a time period of our LSTM as 3. So when during the training, it will take the first two blocks and predict third one, and accordingly train. And so we can see the predicted stock demand for the next 5 days is 231, and that 231 value we will compare with our current inventory value, which we have initially generated using random values, which have been updated after the user has been purchased. So here we can see the updated quantity is 135, and our predicted stock value, stock demand for that specific product is 231. So now since it's lesser than 231, we'll need to restock it. So our store agent will send a restock request to our warehouse agent, and then the and then we can see restock request for 1605 16045 sent
Basically,
from the store agent.
so
Yes.
basically, you are training the data for last 3 4 days and predicting it on the next for the next day, right?
Yes. For the next 5 days.
We are predicting for the next 5 days.
But what about the historical data which you have showed?
They are just storing it, and they are just considering the blocks of last 5 days or so. 3 days, right?
No, so as we explained previously, okay, we train the data based on time periods of over 70 time periods. Now each time period is a span of 5 days. So if you could see our Excel sheet, okay, you can see that there's 70 rows, okay, in each column. So each column is its own product, okay, and we extracted the invoice dates from the previous date. We sorted them by date. We grouped the products together and we added them all up together to find the amount of products purchased in a 5 day period. And each 5 day period, we did that 70 times for each 5 day period. So if you can see our product, you'll see that if you scroll down, okay, if you scroll down, you can see that each row in each column will represent the number of products that have been purchased for that singular product in that 5 day period. And based on this, we predict the next time period's product. So in this case now, if we check to 16045, which is the example we use here, we can see the time periods for all the days. And for that, we predict the next the 76 time period. Okay. So you can see we picked around 274 in the past, 214 in the past, and they've been around 400, 200, 100, 200. Okay, so that's how we predicted the next time periods need, and using that we subtracted the difference and place orders to the warehouse for our new products.
Okay,
So
okay, got it, got it.
okay, so we
Okay,
trained
guys.
it on around 70 into 5, around 1 year worth of data, and we predicted 5 days using that 1 year worth of data.
Okay, got it. Got it.
So team 156, I think so we need to cut it down here.
Okay. Oh, okay.
Okay,
It's
sir.
fine.
It's fine,
Yeah,
right?
it's,
You
yeah,
guys got to know sufficient enough for grading, right?
yeah, it's fine.
I'm sorry. Can you
Good
repeat?
work, team.
Yes, yes. Good work,
Good work,
team.
team.
Okay. Thank you.
Okay, team 56, you guys can leave the meeting now.
Thank you.
And
Thank you.
Jalak, can you please assign the next team who's going to join?
Yes, yes. You all can leave now. Thank you, 156. So next team we have is 158.
Last team was 156, right?
Yes, sir. The next team is 158.
Okay.
Yes. Hello, team 158. Y'all can start presenting and please make sure that y'all finish up in 10 minutes.
Okay. Yeah, I'll
Yeah.
just share my screen. Is my screen visible?
Yes.
Okay, so I'll start. I'm Avni, and my partner is Saad. We're in number 158. So, delving into the problems, the Aryan faced two main problems. One was inventory management issue, and the second was untimely food orders. Focusing on inventory management issues, one problem was the that of overstocking and understocking, and the second was expiration date of perishable goods, and the third was customers purchasing certain goods more frequently than others. Due to these reasons, I'll give an example. For example, flour, which is purchased a lot and is a daily commodity, often leads to understocking as RN would not refill the stock amounts of flour, which would lead to a decrease in sales. So, our solution for this problem was number one, to check stock levels regularly, optimize restock times, as in certain days of the month where restocking would be better than other days. Then, regular restocking of daily use goods like flour, salt, sugar, rice, oil, and also to analyze customer purchase patterns and restock the popular items accordingly. This was done through checking the sales. So the goods which had more number of sales were restocked more. The second problem is that of untimely food orders. Now, this happens mainly because of the suppliers and the providers. Now, one thing that it depends on is the proximity of suppliers. If the supplier is close by or at a far away distance. The second is delay in the shipment. Also, inconsistent quantity and quality. Another problem is that of stock order and the delivery, which is not done timely. So in this case, if Aryan, the shopkeeper, wanted restocking of sugar and the provider took like a long time, maybe a week to deliver it, it would also cause in the decrease of sales. So our solution was to find available providers by checking multiple conditions like proximity, price limit, availability of items, and also develop a user agent and provider agent to establish communication. Following the theme of deep learning, we have included data sets through a tortoise package, and we've also followed patterns to predict customer trends, stock levels, restocking times, and provider availability. So now I'll go to the code. Is it visible?
Yes. Yes.
Okay, so this is the code for booking. What we have done is using Fetch AI, we have developed two agents. One is the supplier or the provider, and the second is the user. Now, for the supplier agent, it follows a supply protocol. Now, in this, we take in some responses like different service types. For example, flour, sugar, and rice, and we add it to the provider services. Then we check availability. For example, the start time, the end time, the maximum distance of the provider and the user. Here it is taken in miles, and the minimum user unit price of a item. The second agent is that of the user. Now, here we've developed a user agent. Now, this takes in the username, the location of the user, how much quantity the user wants, what type of items it requires, and the maximum price that the user has, beyond which he will not be willing to pay. We also have a markdown object, which basically gives the discount. So, starting off, we have defined an event handler which handles the service requests. Basically, it checks the storage and it checks whether the service request has already been completed. If it is not completed, then it sends the details of the request to the supplier. So, when the supplier gets the request, it has to give a response. That response is on the basis of certain conditions. For example, the location, the start time, quantity, services, and the final price, which is marked down into the message price. Moving on, if the supplier is ready and available, then we get a message that supplier is available, attempting to book now. Otherwise, we get a message that supplier is not available. Similarly, we get the final message that booking was successful or booking was unsuccessful. This the two agents, they follow this code that I've written. So the first code is models, which defines the different service types, the user class, the services, the provider, and also availability. The second is the supply protocol. Now, this is the main protocol that the user agent and the supply agent will be using to generate responses and queries. Now, this uses GeoP library. The main use of this is it checks the location of the user as well as the supplier. Now, the location is in the form of latitude and longitude, and it calculates the distance between the two users. Then it checks if the service distance is less than or equal to the maximum distance, which we've given as 10 miles. So it returns in range, which if the service distance is less than the maximum distance, this will come out as true. Otherwise, it will be false. So then, if the distance is, suppose the distance is within the service area, we calculate all the availability, such as we have more conditions, such as the start time, which should be less than the message start time. The unit price into the quantity of units should be less than the maximum price. And we get these messages proposing price or declining request. Based on all of these three codes, the final output that we get is if all the conditions are satisfied, we get accepted task and updated availability. Moving on to the other model that we have, Saad will take over.
Yeah, so having considered the supplier and the user, now we come to the grocery to solve the problem in the grocery store itself. That is that people can forget to order stuff, or people can forget to order stuff or check up on the popular stuff when it is ordered. So if it's not ordered, the other supplier part won't work only. So I have created an inventory management system over here which trains itself on the which you can integrate into the system that the grocery store already uses and train itself on the historical data there is. For example, in this grocery store, flour, atta, sugar, etc. is the most broad things. So it will by the historical data we provide over above. It will learn and when it will learn what is the most popular item. 10 most in this case 10, but we can edit it. 10 most popular items, and as soon as we have to enter the highest amount of quantity that we can store. So as soon as the quantity goes below 20% of the original capacity, the AI over here will automatically connect to the supplier in the first module and place the order itself. And one more thing, that in the end you need more than you can store, because you need more stock than you can usually for the buying. For if there's a higher buying capacity in seasons, that is usually in the start of the month when people restock. So over there also it will keep more 110% of the stock, more 10 to 20%, which can be altered and will be ordered automatically on whatever you can say, and it can make its decision on its own.
So that's it. That's the end of our presentation. Thank you.
You have a demo to show, I mean, working demo.
Unfortunately, we didn't get enough time to form a working demo. So we've developed the entire code, but we don't have the working demo of it.
The problem that occurred while, because both of the models had to learn and we were first times in machine learning, so we were trying to figure out how to train the models, and that took a lot of time. We had to train the models, and the training of it was very new to us, so we were learning part by part and we came to the solution.
Okay. So that's you were saying you will be going to collect the data and then train the model, right?
Yeah,
on
we can connect
on
a
the
database, a CSV file to train the model, but we are still figuring out how to and learning.
so you will collect the data in real time and then train the model.
We can do that, but for the presentation over here, we were trying to take a data from a grocery store database we already found. We can create a real-time data too, and feed the 10 items for that 10 items by hand also, but we want it to be authentic by training because it's a machine learning program.
Can you train the data with can you train the model with real time data? I mean,
Yes,
suppose
yes,
you
yes.
want.
Yeah, yeah.
We can train the model in real-time data. Usually, the grocery store, the systems they use, they provide the output of the sales in a CSV or an Excel format, which we can put into the database in the code and train itself. And if not, I think the solution we were also looking for was not to integrate it within the system itself, the grocery system uses, because not all grocery stores in India also have a system. But as we saw that Aryan was a young person, he could enter it himself in a Excel database and train the model himself.
So, what our idea was that the database of the grocery store, the real time data, would be the front end, which we would then connect to the different user agents, the provider, and the user, and build a model based on that.
But will you get the accurate prediction on real data? Because suppose on day one you have data of day one only, right? And you train the model on day one data only. So how you will get the accurate data for day two?
So for accurate data, we can set a duration. For example, we can start from Jan 1st of the year to maybe 6 months into the year. We can also look upon different seasons, as usually during summer seasons there are sale of seasonal vegetables, whereas in winter season there is a different type of products which are purchased more. And based on the different time durations, we can get an accurate data set which we can apply the data learning model, deep learning model on.
But till then we cannot predict it, right?
But till then, Aryan must, if it depends, if it's a new grocery store opening, then they will have to do some adjustments and predict it themselves. But if it's an already running up and running grocery store, then there shouldn't be any problem to get accurate.
Based on their previous customers, and they can take that data.
Okay.
Okay. So, did you guys ever thought about using the existing data sets available in the market?
We were searching for data sets on Kaggle and different websites,
Hmm.
and but we were figuring out how to train our own model because of by the data set. We started with FetchAI and what it was and everything,
Okay.
but by the time we came to this part, we were still by the time deadline came, we weren't able
Okay.
to
Okay.
figure
Okay.
out how to train it and
So
get
you
a
guys thought about the whole system architecture, but with the time stream problems, you couldn't just happen it to complete your each task, right?
yeah. The code and the syntax, everything we were learning, but as soon as we came to training
Yeah,
the
yeah,
model, it was
yeah.
submission
It's
time.
fine. It's fine. At your level, it's okay.
Any advice for us moving forward?
No, you guys did great. I guess it is good set of code. But from the next hackathons that you participate, make sure that the main purpose, like the main purpose, like model training or whatever it may be, that gets covered rather than giving weightage to more ethics and more overall implementation of the whole workflow. Okay.
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 Yeah.
Okay, guys, thank you so much, Team 158. So, you guys can leave now.
Thank you.
Thank you so much.
Judges, this was team 158. Next team we have is 161.
Which team next? Bullet, can you repeat the team name?
Sir, 161.
Hello, am I audible?
Yes, Emil, you are audible.
Okay, so I'm alone in my team. So should I start or
Yes, yes, Hemel, you can start. I mean,
okay?
Yes, yes, you may
So
start.
can I share my screen?
Yeah, yeah.
Just a second. Is it visible? Hello.
Yeah, yeah. With it.
Okay, so I'm Hemel Shah, and so I would be like I have done my this project on Python basically. So this I have just copied the problem statement over here. So in the problem statement, it is written that he's a family-owned grocery store. He's a family-owned grocery store's owner. So in the data set I have used the inventory data as a data set. I have picked it from Kaggle itself, and basically I have focused mostly upon the sales. There are basically two products. Sales of, like, there is a product named NS and there is a product named GH. So sales of both of these products are provided in the database. So, like, firstly, for doing the process of ML, we need to, sorry, for doing the process of deep learning in the data set, we need to firstly read the data set, right? So, uh, basically, I have read the data using the read underscore CSV function, and the data basically contains 498 rows and 11 columns. So, like this describe command basically it gives an overview of the data, like the count of the number of values in the particular column, right? Like the sales of NS contains 498 values,
and the sales of GS also contains 498 values. So we'll be focusing upon this columns itself. So then comes the representation of the data. So representation of the data, basically it means that the data, like we to present the data in form of graphs, in form of charts, etc., to uh, get a better idea of how the data is situated and how the data is in a flow. So basically, I have represented the data in form of bar chart and bar chart, line charts, scatter plots, pie charts. So here I would like to mention one point over that the blue points are the values of the sales of NS, and these are the values of GH, the green ones. Then the hierarchical clustering is basically the ranges between the dates. Like the dates are hidden over here because like there wasn't enough space on my screen at that time, so that's why. Then comes the analysis of the data. So here is the main part. Inferential analysis is something where we compare differences between the treatment groups. Like here here there is a here we can easily compare by the scatter plot. But if the data would be scattered, like there would be if there would be more data, so here there would be some point where there would be a mix up between the green and the blue points. So at that time, inferential analysis is better. So it contains two values, that is the t statistic and the p value. So the t stat the t statistic uh, basically t statistic is used to test the null hypothesis, and p value is the value of the null hypothesis which we try to perform. Then there is a diagnostic analysis. So it is like in Microsoft Excel also it is used. So like it is usually used to basically uh, dedicate the whole table into whole data into a, what do we say, into a graph where the ranges are considered as points. Like this isn't a single value, it is like uh what do we say, around 20 to 50 points of ranges. Then sorry then then I have used linear regression over here. Basically linear regression is basically like it is used to find out the coefficients and the intercepts of the whole data. So the coefficient means that like if you say, like suppose here we had what do we say, the values, like here we had the values, like there are 498 entries of this and 498 entries of this. Let's assume that he have sold 498 and 498 values in per week both, like 498 products of S, NS and 498 products of I'm sorry, like this is the, we have compared the sales and the CGM of just NS. So if he sells the 498 products of uh, NS in a particular week, then he will be having a loss of 589, like if he don't sell any products of GH. And then like this is the key means clustering. This means that like where are the changes occurring in the, like major changes occurring in both of the data. So here we can see that there is major changes at the end of the data, both of if you compare the both of the data. So then there is this is the time series analysis. So time series analysis basically means that uh, it like how frequently the data is changing over a period of time. So this indicates that overall it has a average of 498, like an increase. So here we can see that here it is just a part of the data that is a part of NS and a part of GH. So we can see that till one point they were growing at a single rate. Like if 200 had a growth of this much, if blue line had a growth of this much, the red line also had almost the growth of that much itself. But if there is a more time, if more time they both are selling the same product, the price will increase frequently more of the red line, that is of GH. Then the smoothness of the data, that stationary and non-stationary. This means that how stable the prices of the both the products can be. So it is regarded by the it is in consideration with the data which is already present. So in both of these cases, the data is non-stationary because in this only we can see that after this time it will increase by a phenomenal price. Then like this part,
Hello,
I was
hello.
not.
Sorry to interrupt you, Amil. So,
Yeah.
Amil, actually, you have exceeded your time limit. So, you just have a minute
Sorry.
now. You have exceeded your time limit of 10 minutes. You just
Okay.
have a minute now to complete the remaining part. Just do it fast, okay?
Yeah. Like so now I will say about the time series, like I explained earlier itself, that like when the time increases, the product has increased prices or not, and like I have represented it by some of the graphs. That's it. Thank you.
Emil, you have a working solution for this, whatever you have done?
Yeah, like I have the codes.
Okay. And here, have you done the stock analysis? I mean, whether the
No,
stock
no,
is available.
like I have tried to keep things basic itself. So like till now what I have learned, like I'm a data science student basically. So till now what I have learned, I have tried to implement that itself.
Have you done EDA?
Sorry.
Have you implemented any pre-processing or EDA steps?
Like I have implemented just a second. I have implemented time series analysis I have implemented, then diagnostic analysis I have implemented, and what do we say? Linear regression I have implemented. That's it. As a major part.
Okay. And what have you used to work with empty data or for the data for the like null values or anything like that? Have you used any step for that?
Like as I said that, like can I share my screen to show the database basically?
Yeah, sure. Go on.
Just a second. So in the data set, as you can sorry, just a sec. Uh,
What is the current accuracy of your model?
like I haven't checked the accuracy because like yesterday itself I made the codes. Like it is like I have just tried to like get the values correct as possible. I guess it is mostly correct itself because the codes I guess are reliable enough, and
Okay. Do
I
you
can
know any methods that we can implement to match the accuracy?
yeah, like firstly we can remove the null values, and then like we can like see I have the data over here. So here we can see, as I told that like we are focusing just on the sales of both the values, that is the B and the G columns. So the other columns I have taken a database where there are values of the sales itself. So there are only a few values of other columns because I am of course the as per the problem statement only sales is required. So
Haven't you used different products for this?
products and like in the database itself, NS is one product and GH is another product. So I have basically compared between, like I am
Two
rotating around these two itself.
Okay, I guess Hemil, we are done from our end. Shubham, do you want to add anything from your end?
Fine. Yeah. Much.
Yeah. So I guess we can wrap this up.
Okay, thank you so much.
Thank you, Hemil. Thanks for your time.
What was
Um,
his team number?
his team number was 161. Next up, we have team number 163.
Hello, Archisha and Rohan. Hello, guys.
Hello.
Yeah, you guys can start now by presenting your screen. So it's
Yes. Rohan will be
4:51. So you guys need to complete it around by 5:05.
sure,
Okay,
sure.
guys? Yeah.
Yeah,
And
Rohan will
Thank
also,
you.
guys, please turn on your cameras, please.
yeah.
Yeah.
Okay.
Hi, Rohan. Hi, Arshita.
Hello. Rohan
Hello.
unmute. Yeah.
Can you see my screen?
Yes, it is visible.
Okay. Can I start?
Yeah, yeah. Go on.
So, a very good evening, guys. So, this is Team Avinya, and it includes me and Archisha.
Okay.
And so, from the problem statement given, we have identified two main problems. That is the inventory management and untimely orders that were specified. So we have assumed that the root cause for these problems would be the unclassified and the unsorted goods, which the guy Aryan would have in his shop, as well as for untimely orders. It would be some kind of logistical issue that he would be facing from his side. So for the solution for the first problem, we have proposed the solution of goods classification using deep learning. So what in the deep learning we have used the CNN architecture, that is convolutional neural networks, for the classification of goods in his inventory. And for the second problem, that is the untimely orders, we have proposed the solution of quick search using DL models. So in this quick search, we have implemented two functions using UAgents library. Yeah. So coming to the second slide, we have for the proposed solution, we have seen some kind of implementation also. So we have taken a API of a grocery data set, and
we have trained our deep learning model on that. And from that training model, we have also classified images using CNN and transfer learning. And whenever customers come, yeah, our approach for the solution, our approach for the problem. So whenever a customer comes to the Aryan shop, so the customer, suppose the customer orders apples and oranges. So the staff will go through his own system and give the price as well as check in the inventory where the oranges and apples are located. And even if the staff doesn't know what kind of order is the customer giving, so they can have a picture of it and can dry run through our deep learning CNN model. From that, he or she will get what kind of order the customer is expecting. So the and for every in this classification, for every product, there's a designated shelf. There would be a designated shelf in the shop itself. For example, the apples would be located somewhere else, and we'll give the apple a unique address within the shop, address or an ID within the shop. I know it sounds some hypothetical situation, and after going to the designated shelf, once the staff takes the order, it would update the stock of the product. For example, there were 100 apples, and right now he wants to give 10 apples to his customer. So he would update his stock accordingly, that is 90 apples. And after updating, he'll come to the billing counter and do the bills and receive the payment of the customer. And customer will also receive its order accordingly. So where would our model help? It would help in the visualization of the orders. Like for example, this is a situation where there was a demand for, out of the whole product sold in a month, the most demand was for fruits, and the second most was vegetable, and third was packages. So accordingly, the owner would think that in what combination should I order to the distributor, so can I can maximize my profit. And as well as you can see, there is a bar chart also for the same. And we have also made a function using UAgents, in which whenever the staff enters some particular order, so from the list it deducts the thing accordingly. And yeah, that's our project about. That is the project about. Thank you.
So, have you guys made any model training or any such things?
Yes,
Okay, so what is the model that you are using right now?
convolutional neural networks.
CNNs. Okay.
Yeah,
Okay, and what is the data set that you guys have used?
it is a grocery data set from
Okay.
Kaggle.
Okay, so you have directly used it from Kaggle.
I have taken the API and integrated in Google Colab.
Okay, okay. So, can you walk us through that, or you want to share the numbers of accuracy of your model?
Yeah, sure. Yeah, okay, I'll do that.
So basically, you guys are thinking about visualizing the selling and
Yeah,
products. Okay.
visualization as well as the sorting. Like for example, the products would have been in disguise previously in Aryan's shop. So we are thinking to classify his products so he would search quickly for the products and deliver to his customers.
Okay. So I just wanted to give you one suggestion from my end,
Yeah.
that you can use this data that you already have for forecasting and for predictive systems, so that he could directly order accordingly to the market trends that you are already providing using data visualization. Okay, so that is just one part. That okay, this is based on the data that we have. This is the best selling product or whatsoever, but it won't cover the market strategies or the seasonal impacts. Okay, so for that you can take the help of predictive systems, and you can you can develop a model architecture. Okay,
Yeah,
so that is based on the supply and demand basically.
yeah. Thank you for your review.
Yeah,
Really
so this
appreciate
was
it.
our code, and like we trained multiple models. Rohan, please go down.
Yeah, you can just walk us through.
Yeah.
Details are not required
So
as of
yeah,
now.
so I'll be just shortening up everything. Those so we trained. This is some of our visualization part. This is some
Okay.
of the images from our data set. Just go down, scroll down, scroll down. Just go to the model part. Yeah. Go down, go down. There were some errors, but still it was working. That is fine. That the errors was from the visualization part. Yeah. So we made five models. The first one was CNN. The accuracy was 1 and loss was almost 0, because the data set which we had did not have a lot of images. So like, since our data was very small, so like there was not much of loss. Just go down, scroll down. Yeah, this is the validation, loss, and accuracy, then test accuracy, and the model summary. Let's go down. This we implemented another model using transfer learning. Iska we it had some very high accuracy and very less loss. Just go down. The next was ResNet 50.
You are
Yeah,
taking input as an image for this particular data set, for this
yeah,
particular model, right?
yes.
Okay.
Yeah, so just go down, Rohan. We'll just show you the test accuracy and the validation accuracy. So yeah, in the ResNet 50, Rohan, Upar. Yeah. So here the validation loss was almost 50% and the accuracy was 1. Matlab, it means that it was overfitted. Then test accuracy also was 1. So it is very evident that it was overfitted. Now Inception V3, this was one of the best models which we had. This and the CNN, simple CNN. Since our data set was very small, it worked very well.
Okay.
So this
In
is
the
a
time,
classification model, right?
yeah.
Yeah. So
So
it
why
was,
you
So
sorry.
chose? Yes, Shubham, you can go on.
Yeah. So
means why you have not used the detection model?
So we wanted to classify whether the demands of fruits, vegetables, or packaged items was more. And once the owner of the shop, like if he had if he had sold a lot of, let's say, fruits, so how much demand, how much he has to order to stock up his shop. The idea was
No,
that was our approach.
class classification will do only the just like the segregating the product, right? But
Yeah.
you cannot uh, count or calculate the quantity, right? Based
So
on that.
yeah, so we wanted to make a model, but that time limits were very less. There were time
Okay.
constraints. That was our idea, but yeah, time limits were very
Okay.
less.
So just feedback from mine would be that whenever we need a forecasting and if it is doable without using images,
Yeah.
just from the number data set, you can
Yeah.
just use numeric data of the
Hmm.
invoices or whatsoever it may be. So
Hmm.
that could shorten down your efforts. Okay.
Yeah.
And we can use classification as in when we don't know, the user doesn't know what is the product outcome, right? At that time, you may use the CNNs. Okay. Yeah, this is just a positive feedback from my end.
Thank you.
Otherwise, good efforts, guys.
Thank you.
We can wrap it up.
Have a good day. Thank you,
Thank you
guys.
very much.
Have a good day.
Uh, Thank you so much. Thank
Thank
you
you so
so much
much,
for
Team
your this.
163. You guys can leave now.
Yeah.
We'll be moving to our last team, which is 164. This was Team 163.
Hello, Tapan, are you there?
Yes, sir.
Hello, Tapan.
Hi.
Yeah, your team is there, right? Yeah.
Yeah.
Yeah, you guys can start now. And the time limit is 10 minutes, guys. So it's 5 6 right now. So you guys need to complete it by max to max 5:20.
Okay. Just a sec. My other teammates are coming. Wait.
Okay, yeah, sure.
Uh,
Uh, is my screen visible?
Yes,
Hello?
yes. Yes, yes.
Okay. Hi. So my name is Rishabh Lalwani, and we are presenting our Cypher Advanced Level solution. Our team name is Control All Defeat, and our team number is 164. Our team consists of me, Rishabh Lalwani, Tapan Patel, and Akshata Moore. So the table of contents for this presentation is going to consist of the agenda, a solution towards this agenda, and our implementation. So the agenda that we saw in the problem statement was that the client Aryan had a family-owned grocery store that struggled to handle the inventory management and the untimely orders with the supplier, which caused the business to decline and lead to poverty, which essentially led to the problem statement of us designing a deep learning AI to help with his business. Now, our solution to this particular problem was to design an inventory management system with the help of deep learning and with the Fetch AI integration. And our solution actually consists of 4 phases. Our first phase was finding a real world data set or creating our own simulative data set. Phase 2 consisted of implementing a deep learning model, which is known as LSTM. Our third phase was integrating the U agents to the deep learning model, and our final phase was designing and implementing the GUI. Now, when it came to designing the inventory management system, we saw one of the approaches where instead of as one of the approaches that we saw came with inventory management system is that instead of creating a normal inventory management system, we decided to predict the return orders that were going to be coming from the suppliers due to the as it was in an unpredictable state from the supplier issue. Now our data set. Now we tried to find a situational data set, but unfortunately we weren't able to find a data set that was useful for our particular criteria. As such, we created our own data set and we populated it using the pandas field with randomly generated data. Our data set consisted of 7 labels and approximately 2,500 entries within the data set. And this basically includes of component, and this labels essentially have consist of components like the product name, the product description, the the product quantity, and the current inventory, the time taken to order, the time taken for delivery, and the total number of sales that were generated. Now, the reason why we did take such a large data set, or why we generated such a large data set, was so that it would help the model to generalize more onto the data set, and it would also increase the complexity of the model, and also would help graph the trends out much more easily, making a much wider array. Now, the deep learning model that we had implemented for this was using a long short term model, or LSTM. Now, the long Okay. Now, in the long shot, now LSTM is one of the types of a deep learning model, which is a much more advanced version of the recurrent neural networks model. Now, uh, since the LSTM now since this application is mostly time dependent data, where we had to predict the return orders. Uh, the LSTM was actually designed to capture and learn patterns in the sequential data, and so that would help in the predicting of the reorder points. Now, LSTMs do have an ability to retain information over long periods of time, which is crucial in scenarios where past events influence the future outcomes. This network can help to learn the relevant information about past sales, orders, delivery times, allowing it to make better predictions. Now, LSTMs can also automatically learn and extract important features from the input data. Now, the U agents were essentially the crux of this, were the crux of the entire implementation. Now, these agents were were a product from Fetch AI, and they're autonomous entities that operate on the decentralized platform of Fetch AIs. Now, the advantage of such a agent is that multiple agents can exist within the same project. So I can have so for example, within this project, I can have an agent that is only applicable towards the supply issue. I can have another agent that deals with the inventory management. And as a result, due to these multiple agents, they can have responsibility over these different domains and can handle messages and the communications with one another. These agents are also dynamic and less resource expensive because if there is any change in the trend, because if there's a change in any trend of the data, the UI agent will be able to understand it, and they will be able to change accordingly towards it. Being lesser resource expensive is also critical towards this to the requirements of the client, as it is more as the UI agent prides itself on being a cleaner source of implementation, as it takes lesser energy, thereby making a much more greener source of an implementation of the supply chain itself. And the UI agents of Fetch AI are also capable of predictive analysis because these AI agents are capable of integrating along with the capable of integrating with machine learning models or deep learning models, and are able to make predictions based upon the data set. So suppose if there can be a request that is sent automatically from the U agent itself, there is the U agent will be able to make the predictions by understanding from the data itself. Now for the GUI, we have essentially built the GUI using the Streamlit library. Now Streamlit is essentially an open source Python library, which requires very little to no web development experience at all. And due to it being Python, it is a popular choice among data scientists and for quicker deployments for web-based applications. It is also seamlessly able to integrate with other projects for real-time templates, which is useful for real-time monitoring. And not only is it capable of making an interactive GUI, it is also useful in making decision making, as you can change according to the parameters for your decisions. That finishes with the presentation. I will be sharing the implementation in just a moment. Okay. Hello. Is my screen visible?
Yes.
Okay. All right. Yeah. So we have the implementation, which is written over here, and so the first step was that we imported all of these libraries. So we had imported Streamlit, we had imported Pandas, because Pandas was helpful in the data. Pandas was helpful in the data pre-processing and the cleaning. We had also implemented SK. SK model implementation, SK model selection for splitting the data set between the training and the testing data set. And we had imported, and to prevent the overtraining of the LSTM model itself, we had implemented a dropout function. So with the dropout function, essentially some of the nodes within the architecture of the LSTM will get shut off. As a result, there can be different variations within the model itself, so that it doesn't, so that the model cannot be overfitted. We have also implemented another countermeasure for preventing of overfitting by implementing an early stopping. So in case if there is an opportunity, so in case if there is a situation where if the model is giving the same uh, output consistently, it will stop itself right there and it will consider that as a trained model. Then we had set the two targets as the X target and the Y target. And the X target we had set as historical sales, product quantity, supply order time, delivery time taken, and current inventory. The Y is the reorder point. Then we have also split the training data into training and testing and validation data sets. We had also reshaped them for input data for LSTM, and this is the model creation for LSTM. So we had defined the model as a sequential model, and we had made the first layer of the model with the activation function for value for each of these nodes, and with a dropout rate of 30%. In the second layer of the model, we had also implemented 50 nodes, and we had kept the activation as ReLU. Finally, since we are only predicting one singular output, which is the target value, reorder point, that is set as 1 unit. That is set as 1 unit. Then once when the model is once when the model is trained with the optimized values, it will save the weights in a keras.h5 model. Then using this, it is a critical aspect of it because we can load this model into the my agent. Now implementing with the agent was somewhat easy because essentially we had to load the model to make the prediction of the reorder point, and similarly we had to import just the previous values of the saved file. And after that was done, we had to find the starting index for setting the weights. And once when that was over, we then compiled the model and made a prediction. We then created an agent instance, and then we then created an agent instance with the finalized loaded model weights, so that it can fully complete the prediction. This is then finally we come to the Streamlit application implementation, where we first define the title of the web-based application as inventory management system. Then we selected the product category as a drop-down function as select product category, which we mapped it to the product category. So, like for example, if you needed like a dairy-based goods or a meat-based goods, that would be your decisions. Then after that, there would be another selection which was called the product category.
Fine. This is fine. Can we see the demo if it is ready?
Oh, the demo.
Yeah.
So we have a GUI based off on it, but so one of my colleagues will be able to share it with you if that's all right. The final model that is somewhat of an issue because of the data set because of the data set. Else the GUI is fine. The code is essentially bug free.
Yeah, so I'll share that screen with you
Okay, guys,
about
just a
the
moment.
GUI.
Sorry to disturb you guys, but actually, you guys are above the time limit. So if you guys have something left, you guys need to present it in within 2 to 3 minutes.
I'm
I
sorry, I
think
couldn't
we
hear
should
you.
show the SS then.
Sure, I'll
The
show the
GUI.
screen. Sure, I'll show the screenshot right away then. Just one moment.
Okay, guys.
So, what is the accuracy you are getting for the model, whatever the model you have trained?
Oh, the accuracy we would get. So the accuracy we were getting was at a 60% accuracy rate, and the mean absolute error we were getting was at a 6%. Now, because most of the what's it called, the data set was synthesized artificially, and because most of the data set was synthesized artificially, we weren't able to bring that number down. So the best number we could pull it through was at 59%, and
And
this
what
is
are
our
the number
GUI.
of products you were? What are the total number of products that you have used for this particular data set?
The total number of, so there were 2,500 entries within the data set. So that's like 2,500 products.
within which we had 9 categories of the products.
So nine. So total there were 9 products, right?
Yes.
So what is the dense layer of your model architecture?
The dense layer. So we have kept, wait 1 second. The dense layer, we have kept it as 15 nodes.
Okay, no worries. Yeah, you can show us the GUI. Continue.
Uh, so yes, this was our GUI that we had kept. Now, the problem was just with the predictive reorder part of it, because we weren't able to figure out how we could like make it predict at that point of time.
Okay. Okay, no worries. What? Okay, so this is your main wholesale GUI.
Yes, that's the entire GUI.
Okay. Okay. Okay.
Okay, guys. Thank you so much.
Thanks for your
Judges,
time.
do you have anything left? Like any questions or something left?
No, no, that is fine from my end.
That is fine.
Yeah.
Yeah, it's fine
Yeah.
from my side.
Okay. Thank you so much, team, for joining in. You guys can.
Thank you.
Thank you,
Thank
team.
you.
Thank you so much, judges. We are extremely sorry for the time delay. And also, we would like to thank each and every one of you for participating in our hackathon. The event was enhanced by your passion and coding skills, making it an incredible success. Deep gratitude to everyone for staying engaged throughout. We appreciate your commitment and we hope you enjoyed the 18-hour coding marathon. We really appreciate the valuable contribution of our distinguished judges who not only provided the knowledge but also helped to shape the hackathon with their evaluations. Your commitment and time has been really crucial in transforming this event into a genius showcase for creativity and brilliance. Thank you for being a vital part of it. Judges Shubham and Janvi, so can you all have anything to say?
Yeah, these items isn't something we could learn from or something, some type of special notes for us.
Okay. I guess to make it more overall, the participants were quite good. Okay.
Yeah.
According to the academically level, they are quite good, uh, lightly equipped, I can say. Next time, you can make things more precise. Like
Yeah.
you can give a data set, same data set to everyone. Okay, so it would be more convenient to judge them on the basis of their knowledge and their approaches. Secondly, you can ask the this PPT prior, like one day before or so, or so that it would lessen the time for them as well. Or you can also set a set of rules for PPT, that you can add this 2 slides for GUI, 2 slides for code presentations, and 2 slides for your demo or whatsoever it may be. So it would be easy to judge them if we have a streamlined set of questions for them pre-handed.
Yeah,
Okay.
ma'am.
So because we saw that many potential candidates couldn't do much better because lack of guidance they had. Okay. So you guys can make that work around, and so that it would be better for them as well, and as well as for the judges.
Yes, ma'am. Thank you
That's
so
the only
much.
thing we could say.
Shubham sir, do you have anything to add?
I think Janvi has added most of the things. I think it was a good event, and the participants were also good. Some of them are really good. Their technical knowledge was I never thought of they have done so far in the. I think this is final year, right?
So the participants were from all like from all the years, like they were from the first year to the fourth year, all of them.
Okay, okay, yeah, but they have pretty good knowledge of this data science, deep learning, and all those stuff. So I think they have done pretty well. And yeah, and maybe you can do a little bit of this management issue. You can figure it out yourself. You can do it much better. Rest thing, I think everything was fine.
Yes, thank you so much, sir. I think we can wrap it up now.
No.
Yeah, thank you so much, guys. Bye bye.
Thank you to
Have a
all the
nice
judges.
day.
Thank you so much,
Last
sir. Thank
last
you, ma'am.
question, Jalak.
Yeah,
And
ma'am.
uh, when can we expect some certification or whatever? In how many working days for us?
No, ma'am, we will try to get that done as fast as possible. As I told you
Okay.
recently, yeah, that there are some issue with LinkedIn. So we are going to sit after the cyclotron, that is tomorrow. Okay.
Okay.
So we will
Okay.
try to figure it out tomorrow. And if there is update, I'll just tell the person to
Hmm.
get in touch with you.
Okay, no worries. It is just for a tentative, just a tentative question.
Yeah,
Nothing.
yeah, yeah, ma'am.
Okay, no worries. Thank you for
Thank
your
you.
Thank you,
time,
ma'am.
Jalak.
Thank you.
Thank you, ma'am.
Thank you. Thank you. Yeah.
Nice day.
Bye, guys.